So question 6, if Tanisha has $100 to invest at 9% per annum, which means annually, and it's compounded quarterly, so quarterly, kind of remember that's that 4 times a year, how long will it be before she has $150? So if compounding continuously, how long will it be? So let's start with quarterly. So how long means they're actually looking for the time. So, and since it's talking about quarterly, we're not talking continuously, so we're using one or two formulas. These formula that I see is the one that just says A is equal to the principal times 1 plus R over N to the NT. So again, if Tanisha has $100, that sounds like the present value or principal, which would be 100. Invest at 9%, that's our rate of interest, which is 0.09. It's compounded quarterly, so N would equal 4. How long will it take before she has $150? So we don't know the time, but we do know the future amount or the final amount is 150. So if I substitute in the formula, I'm going to rewrite the formula though as P times 1 plus R over N to the NT is equal to A. I always like to have my known on the left side. And since we don't know what T is, I like to put that on the left side. So we have 100 over here. We have 1 plus the interest rate, which is the 0.09, divided by N, which was the 4, raised to the NT. So that's going to be 4T, because we don't know what time is. And then the final amount was 150. So one thing we want us to do is solve this equation for time. And we're actually going to use algebra to do this. So to solve for T, one of the first things to do is get rid of this coefficient out in front of all this. So I want to get rid of that 100 by dividing by 100 here and dividing by 100 over here. By doing so, that leaves me then this 1 plus this 0.094. Let's go ahead and divide 0.09 by 4 as well. Let's clean that up. So it's going to be 0.0225. So we don't want to round anything to the very end. So that's still the exact answer there. And 150 divided by 100, that's just going to be 1.5. Because remember, if you divide by 100, you're just moving the decimal 2 places to the left. Oops, raised to the 4t. So I need that 4t there still, because we have to have a variable. So that 4t has to come down too. So notice how I can actually add 1 to that, 10225. So that's just really going to be 1.0225 raised to the 4t equals 1.5. So to solve for t, notice that t is in the exponent. So to get t out of the exponent, that's where logarithms come into play. I'm going to take the log of both sides. So I'm going to take the log of 1.0225 raised to the 4t. And I'm going to take the log of this side. That's going to be log of 1.5. So you can either use the common log or the natural log. So you can use either the ln or the log button on your calculator. Remember, log is a base 10 and ln is a base e log. Those are the two that are easiest to get to. So since these are logarithms, the proper logarithm says this 4t can come out in front. So this 4t log of 1.0225 is equal to the log of 1.5. So remember, these logs represent numbers. So to get t by itself, the 4 and the log of 1.025 have to go away. So I'm going to divide this side by 4 log of 1.0225. But I also got to divide this side by 4 log of 1.0225. So by doing so, t is going to equal the log of 1.5 over 4 log of 1.0225. So that would be the exact answer. What they want us to do, though, is they want us to round this 2 decimal places. So I'm just going to put that in the calculator then. I'm going to use the fraction mode. So alpha F1. So I'm going to have the log of 1.5 on the top. Oops, I need a parenthesis up there still. And then 4 log of 1.0225. And that gives me then 4.55. So I say round to 2 decimal places. So 4.56. So 4.56 years would be the answer to that problem. I think the years were all, you don't have to write the years in. I think that's already going to be given to you. So that's how long it's going to take to make $100 turn into $150 at 9% compounded quarterly. Next question says, how long will it take if it's compounded continuously? Well, if I'm compounding continuously, we have P is equal to, I'm sorry, let's use the A formula. So the final amount, A is equal to P times E to the RT. So again, the A was the 150, but also again, we're looking for time. So I'm going to rewrite this as P E to the RT is equal to A. So the present value, or the principal is 100. We have E, the interest rate was that 9%, so it's going to be 0.09 T, and it's going to equal then the final amount, which is 150. So again, I want to solve for T. One of the first things I can do is get rid of this 100. So if I divide each side by 100, I can get rid of that coefficient, if you will, by using division. So it's going to give me this E to the 0.09 T equals 1.5. Since this is a base C log, it's not a bad idea to just use the natural log. So if I have the natural log, I keep doing that. Don't know what that's all about. So the natural log of E to the 0.09 T is equal to 1.5. Now remember, the proper logarithm says this 0.09 T can now become a coefficient. So I have 0.09 T, and then this, I have this natural log of E is equal to then, oops, I take the natural log of both sides. Remember, the property equality says what you do one side, you got to do the other. So that's got to be the natural log of 1.5 over here as well. Okay. So like I said, the 0.09 T does come out in front, and then you have the natural log of E equals then the natural log of 1.5. Now remember, the natural log of E is 1. So that just leaves me 0.09 T is equal to the natural log of 1.5. So all I got to do is divide both sides by 0.09. So it's going to be the natural log of 1.5. So I have a little bit more room down here. And we're going to divide that by 0.09. So they do, again, want the answer to 2 decimal places. So if I do the natural log of 1.5, and if I divide that by 0.09, that's going to equal then 4.51. So T equals 4.51. So by compounding continuously, it does take less time, just not by much. So that would just be 4.51 years. So compounding continuously should make it happen quicker, just not that much quicker. So again, like I said, if you didn't know the natural log of E was 1, you could keep it in the problem. But if I type it in here, natural log of E to the power of 1, notice that it does equal 1, because remember, E to the what power is E would be E to the first power. So remember, when you do the logarithm, you're looking for that exponent there. So we kind of got that going on there.